So 4.6 is where we are now. So tangent and cotangent graphs. So first off, let me list a few things about the tangent function, and then I'll bring up a picture of a graph, and then we'll talk about how we do the different transformations. So tangent. Tangent function is odd. So that means it's going to have symmetry about the origin. F of x is negative f of negative x. So we get this symmetry about around the origin. Tangent function is increasing. That means from left to right, it's going up. Its period is pi. So that's a little different than sines and cosines. So its period is pi. So it repeats itself every pi units rather than 2 pi units. Now, something interesting happens because tangent theta equals sine theta over cosine theta. What happens to a graph of a function when we have a fraction like this and we divide by 0? We have a vertical asymptote. Very nice. So we get a vertical asymptote when cosine theta equals 0. So when is cosine theta equal to 0? Where on our unit circle is cosine theta equal to 0? So the point 0.01. So what is our theta value? What is our angle at 0.01? That's our angle. Pi over 2. And then we get another cosine is 0 again, down here at 3 pi over 2. And then again, add another multiple of pi over 2. So anytime we have a multiple of pi over 2, the way we write that is theta equals pi over 2 plus n pi, where n is an integer. So we go halfway around the circle, we get another cosine equals 0. Go another halfway around, another cosine equals 0. Another halfway around, so we're adding multiples of pi. So we get an asymptote every pi over 2 units with our tangent function. So let me grab a picture of the tangent of a tangent function. So there is a picture of our tangent function. Here are my two asymptotes. So I have one at negative pi over 2. So that would be pi over 2 minus pi. And a positive pi over 2. So there are two asymptotes. My function is increasing. Goes uphill from left to right. It's odd, so it's symmetric about the origin. And it repeats every pi units. So this is what an unshifted graph of a tangent function looks like. The red curves are our tangent functions, and we get these vertical asymptotes every pi over 2 units. So we're going to use this information to graph our shifted and stretched tangent function. We know our period's pi. We know where our asymptotes happen when our function's unshifted. So we're going to apply that and use to graph our our function when it is shifted. All right, questions about this information? Okay, let's talk about how we graph this. So we're going to talk about everything, all of our different shifts at once. So y equals, I'm going to put the d out here in front. And let me go back here really quickly. Notice that we don't get this oscillating thing like what happened with sine and cosine. So it really doesn't make sense to talk about an amplitude because we have these vertical asymptotes. So when we talk about our A, we don't really talk about an amplitude for the tangent function. So our information here, D still gives us a vertical shift. That doesn't change. A tells us our vertical stretch. Or compression, depending on how big A is. Our period is pi over B. And then our horizontal shift is C over B, just like with our other function. So I'm going to factor out this B. So C over B is going to give us our horizontal shift. The only other thing we need, a couple of other things we need to know is to find our asymptotes. What we're going to do is set this bx minus c equal to negative 2 pi. Or sorry, not negative 2 pi, negative pi over 2. Solve for x. And bx minus c equals pi over 2. And solve for x. Because our unshifted tangent function has two successive asymptotes at negative pi over 2 and positive pi over 2. I could set that equal to 3 pi over 2 as well and solve it. That would work also. We just do this because we have this this symmetry around the origin. So this is going to give us our asymptotes. We get an intercept halfway between the asymptotes. So an x intercept halfway between asymptotes. And then to get a couple of additional points to take into account our vertical stretch, or A, we're going to say y equals plus or minus A halfway between an intercept and an asymptote. And we're talking about the x-intercept. So this is going to give us our, take into account our stretch, our A value. And we say plus or minus because our tangent is increasing. So it would be minus A over here to the left of the intercept, and it would be positive A over here to the right of the intercept. And with cotangent, things change around a little bit. So this is how we're going to graph. We're going to use this information. The difference is we get these asymptotes. Our period is pi over b rather than 2 pi over b. But our shift, our stretches, everything else is the same. And then our intercepts and our asymptotes are going to happen every period. So we're going to have one period between the intercepts, one period between the asymptotes. That marks our repetition, our interval of repetition for this. All right, questions on the information here? All right, let's use this to sketch the graph of a tangent function. So we're going to graph y equals 2 tangent 2x minus pi over 2. I'm going to rewrite this right away because we have this 2 here. We need to factor that out. 2 tangent of 2 x minus, when we factor this out, we're dividing it. Pi over 2 divided by 2 is pi over 4. So my a is 2, so we're going to get a vertical stretch of 2. Our period is pi over 2. And we're going to shift right by pi over 4 units. So that's all my information here. And then we're going to find our asymptotes. We're going to say 2x minus pi over 2 equals negative pi over 2. And I add pi over 2 here to both sides, and I get x equals 0. And I'm going to say 2x minus pi over 2 equals positive pi over 2. Add pi over 2 to both sides, so pi over 2 plus pi over 2 is pi, and then I divide by 2, so I get x equals pi over 2. And now we're ready to sketch. So I have a vertical asymptote when x equals 0. I have a vertical asymptote when x equals pi over 2. And our period is pi over 2 units. So I'm going to, I'm just going to go ahead and put another, why don't we do one in the negative direction here. I'm going to put another asymptote back this direction to the left here. And this will be negative pi over 2. Intercepts halfway between the asymptotes. So halfway between 0 and pi over 2 is going to be pi over 4. And we'll have one here at negative pi over 4. And then halfway between the intercept and asymptote, my function is going to be plus or minus 2. So I'm going to go 1, 2. So that's 2 and negative 2. Halfway between 0 and pi over 4 is pi over 8. So there's pi over 8, 2 pi over 8. So this is going to be 3 pi over 8. And then I can just go backwards with this one. Negative pi over 8 and negative 3 pi over 8. And my function is going to be, we know it increases. So I'm going to have a point here. And I'm going to have a point here. I'm going to have a point here and a point down here. And my graph is going to look like this. And like that. And that would be a rough sketch. So this one's kind of stretched out a little bit the way I drew it, because we have this vertical stretch of 2. And that would be a sketch of 2 periods of that tangent function. And this would be the information that I would look for on your axes, and you'd have your points here to account for your stretch, your y-axis labeled, and all of these points accurately labeled on your graph. So we get an intercept every period from negative pi over 4 to pi over 4 is pi over 2 units. We get an asymptote, vertical asymptote, every pi over 2 units. And all of these points repeat every period. All right, questions on that? Okay, once we have this, the cotangent functions are pretty easy. So let's talk about our cotangent function. Cotangent. Cotangent function is odd. Cotangent function is decreasing. So decreasing means from left to right is going downhill, going down. Odd, decreasing. Our period is pi again. And because the cotangent of theta equals cosine theta over sine theta, we get a vertical asymptote when sine theta equals 0. And sine theta equals 0, when does sine theta equal 0? When theta equals 180, or in radians, pi. So we get sine theta is equal 0 pi, and then again at 2 pi, and again at 3 pi, and again at 4 pi. So we get multiples of pi. So the way we write that is theta equals n pi, where n is an integer. We get an asymptote at 0 pi, 1 pi, 2 pi, 3 pi, etc. So our asymptotes, the big difference between tangent and cotangent, cotangent is decreasing. So rather than going up from left to right, it goes down from left to right. And we get asymptotes at multiples of pi rather than asymptotes at these multiples of pi over 2. So let's look at a picture of our cotangent function. Grab that. There, yes. And this says 1 over tangent x because this program didn't have a cotangent function, just so I had to do it as a reciprocal of a tangent. So there's our cotangent function, a graph of our cotangent function. We have an asymptote, vertical asymptote at 0, x equals 0, and at x equals pi. We're decreasing. All the other information is the same about the cotangent. We get an intercept halfway between the asymptotes. Halfway between the intercept and the asymptote, y equals plus or minus a. So we're going to go about sketching our graph the same way. So if we have y equals d plus a cotangent dx minus c, all the information that we wrote for tangent, our vertical shift, vertical stretch, period is pi over b, our horizontal shift is b over c, all of that's the same. The only difference is that cotangent is decreasing, and our asymptotes when bx minus c equals 0, so we're going to get 2 successive asymptotes, and bx minus c equals pi, because our unshifted cotangent function has an asymptote at 0 and pi. We set that bx minus c equal to 0, bx minus c equal to pi to find 2 successive asymptotes for our shifted function. All the other information that we said about the tangent function is exactly the same. And then we got our points, our y equals plus or minus a, halfway between the intercepts and the asymptotes. The intercept is halfway between the asymptotes. All that information is the same. So I'm just going to say all other info same as tangent function. So our process is going to be the same. We just need to make these little adjustments. All right, questions there? Questions about our information? Okay, I just want to do one graph, one sketch of a cotangent function, and then we'll be set. So we're going to sketch y equals 3 cotangents of x plus pi over 2. Well, this one, our A is 3, so we get a vertical stretch of 3. We don't have anything in front of the x, so I don't have to worry about factoring anything out of our parentheses here. So our period equals pi, and we get a shift left by pi over 2. Okay, shifting left, we get a, we find our asymptotes. When x plus pi over 2 equals 0. So that tells us x equals negative pi over 2. And when x plus pi over 2 equals pi, and that tells me that, sorry, that's right, and then x equals pi over 2. So I get one vertical asymptote at negative pi over 2, another one at positive pi over 2. And now we're set to make our, start making our sketch. So here's one asymptote, and here's another one, and we'll do one more out here so we can sketch 2 periods. So we're at negative pi over 2, and our period is pi, so pi over 2 plus pi is 3 pi over 2. We're going to get an intercept here at 0. We're going to get an intercept here halfway between pi over 2 and 3 pi over 2, which is at pi. And then we're going to get our points halfway between our intercepts and our asymptotes. And that's where, I'm just going to sketch this in and we'll label our y-axis. In just a second. Our function is decreasing. So there's going to be what our function looks like, and then we just have a couple more points to add in here. Halfway between 0 and pi over 2, this point is going to be pi over 4, and that point on my graph is going to be at negative 3. And this is going to be negative pi over 4, and that point is going to be at positive 3. And this point would be 3 pi over 4, halfway between pi over 2 and pi. And that point's going to be at 3. And this point is going to be 5 pi over 4, halfway between pi and 3 pi over 2. And that's going to be down here at negative. So that would be my sketch of my cotangent graph. For these graphs, how can we find a point if we can't calculate it, or we're not sure off the top of our head? How do we find a point halfway between 2 other points? So if I didn't know that halfway between pi and 3 pi over 2 was 5 pi over 4, how would I figure that out? Find the average. So add the two together and then divide by 2. That's how you find the point that's right in the middle. Find the average. What do you notice about how this graph looks? What if we flipped this over the x-axis? What if we reflected this over the x-axis? What would it look like? It would look just like a tangent function, except we have this vertical stretch. So if I shift a cotangent function by pi over 2 units and reflect it, I get a graph that looks like the tangent function. So that's how tangent and cotangent are related. We can think of it as a shift and a reflection. Sine and cosine, we can think of them as a shift from each other. All right, questions on graphing tangents, cotangents? So the big difference are period with pi, and then for the tangent and cotangent, we don't have this oscillating thing going on. We have these asymptotes that happen every period. Okay. All right, there you go.